Hey everyone, and welcome to the tile scrolling game number 6. Today is another really exciting day because we're going to be improving the visual look of the game quite a bit by adding in the background on top of the lighting engine. That way we don't have to stare at this background that's boring, kind of like me. But before we get into this video, make sure you hit that like button and consider subscribing, and also drop a comment down below. But without further hesitation, let's just get into this tutorial. Okay, so I have one new sprite and it is called background. I bet you don't know what's inside of it. Oh wow, it's the background. So the first one is called clouds. It's an infinitely looping background. What I mean by that is I used an external pixel art program called Aseprite to draw these, and then I just turned on tile mode. So that way it perfectly is seamless. Then I exported it and imported it into Scratch, and this is what it looks like. And all of these backgrounds are perfectly 240 pixels wide by 180 pixels tall. I found that it fits perfectly on the screen, and then I have dirt underground, which is also seamless. And last but not least, I have cavern background, which is the stone layer. As you can see here in Aseprite, this is where I actually drew this pixel art, and if I go to view, tiled mode, tiled in both axes, I thought it was axes. As you can see here, these clouds are perfectly seamless, so it makes it really handy to draw seamless backgrounds, because say like right here, I could draw a circle, fill that in like this, and cool, it's a circle. But then if I go into view and turn off tiled mode, this is what it actually looks like. But once we put a bunch of them together, it'll perfectly loop. And it's the same for all the other ones. These are all seamless. And then in the backdrops, I have the old backdrop we've been using, which is just blank. And then I have one called skybox and underground. The skybox is for the surface and the underground is for the underground. Okay, so let's start into the backdrop. So of course, click onto the backdrops and add a when green flag click, then make a custom block called reset, and make sure you check run screen without refresh and run reset in the beginning. Go ahead and go to 00, switch costume to clouds, clear the graphic effects, show, and then go to the back layer so it's behind everything. Okay, so let's go ahead and test this out. If we click the green flag, look at this, we have some clouds in the background and the skybox is there and everything looks good. And the clouds are separate from the background, which is very good too. Okay, so let's go ahead and make a bunch of clones for the backdrop. We need one right in the screen, above the screen, then above to the right, and then just to the right. So make a custom block that will handle this called create background clones, like so, and make sure you click run screen without refresh, and then run that block after the reset. Now to actually position the background, because this game is scrolling, we need some x and y variables. Make a for the sprite only variable called underscore x, and then another for the sprite only variable called underscore y, and then go ahead and set the x and y to 0, 0 here, and then create a clone of myself. And then we need to set the x to 1 background to the right. Now to do that, we need to figure out the width of one background. So go ahead and make a for the sprite only variable called sprite width, and then sprite's height. Both of those are for the sprite only. Now in the very beginning, set the sprite width to a times operator, and now take the size divided by 100 and put the width of the sprite in the left, which if we look here is 240 for all these backgrounds, so do 240. Now duplicate this and set the sprite height to the amount of pixels for the height, which is 180. So set it to 180 times all that. And if we start this game, you can see that the sprite width is 600 and sprite height is 450. Okay, so now we can actually move the background by one background to the right. So go ahead and for the second one, set the x to sprite width, duplicate this, and take out that and put the sprite height for the y. So this one is above the middle one. And then the last one, we'll set it to sprite width and sprite height, and then take out this create clone of myself. Now we need to figure out the base position of the background, which was just the scroll x minus the x position and all that stuff. So we can go ahead and store those in a variable. Make a for the sprite only variable called mod x, and then another one called mod y. Now go ahead and set the mod x to the x minus scroll x and take that times 0.2, and that'll make the background move a little bit slower. Duplicate this and set the mod y to the y minus scroll y times 0.2. Now we need to make the backgrounds loop to the correct position, so set the size to a really big number. Go to mod x mod the sprite width times 2, like so, then subtract off the sprite width and put that in there. Now for the Y, you want to go ahead and duplicate this and change this to a mod the sprite height times 2 minus sprite height. Then once we're done moving it, we can go ahead and set the size to 250 so it scales correctly, and let's go ahead and test this guy out. So hopefully if we've done everything correctly, you should see some clouds. Yep, I do see some clouds, but they're looking kind of weird. Inside of here, we want to take the scroll x times 0.2, not the whole thing. So if we go ahead and pull this out and then put scroll y in there and then put that back, this is actually how it should look. This is promising. It's looking good so far. If we keep walking, it should infinitely loop. I think this is working. And the cool part is if we do like switch costume to Dirt Underground and start this game, it should also be infinitely looping and looking seamless. Yep, look at this. We have a dirt background that's looping and it looks great. And the even better part is if I go ahead and take this instead of times 0.2 times like 0.8 or something, you can see that it automatically updates, and now look at the background moves faster. Oh man, that's awesome. Okay, let's go ahead and change that back to 0.2 for now, and then the clouds. Now instead of making this rigid to where we have to manually change this, let's make a background meta that will contain all the different backgrounds, their costumes, and the speed. That way we can switch them. Inside of the stage, go ahead and add a custom block called create background meta, like so, and click OK. Then run that right here. Now we need a list called background meta and delete all of that right here. Now make a custom block called background entry with a colon, then name with a colon, and an input name, parallax speed with a colon, and then an input speed. Make sure you tick run screen without refresh and click OK. Now inside of here, all we need to do is add name to background meta and add the speed to background meta. Then inside of here, we can pull out the new background entry and fill in the data. So the first one will be clouds. The parallax speed will be 0.2. Duplicate this. The second one will be dirt underground. The parallax speed will be 0.15. Last but not least, the last one will be cavern background, and the speed will be 0.1. Make sure these names match the costume of your background. As you can see, these are all named the same exact thing as the items in the list. So hopefully if we start, yep, look at this. The list contains a name and then the speed of it. Cool, so now we can actually use this. So make a for the sprite only variable inside of the background called parallax speed, and set that parallax speed to the item in background meta, and then put +1 inside of here, item number of thing in background meta. And instead of thing, go ahead and make a variable called background and click OK, and then do the item number of background in there. Now if we do +1, that'll give us the parallax speed. Set the background to clouds, like so, and then inside of here, switch costume to the background. So if we start this game, you can see that everything works exactly the same. However, if we change the background to Dirt Underground, you should see that the parallax speed is different. Yep, it's 0.15 now instead of 0.2. Okay, let's change that to clouds. Now we need to change the background depending on the height of the player. So add a forever loop and check if else the scroll Y is greater than a value. Now we need to actually figure out that value. Show scroll Y, go into the player and set the Y to like 7,000. Okay, that's getting underground, maybe 6,500. You know what? 7,000 seems like a good threshold. So in the background, if the scroll Y is greater than 7,000, then we'll set the background to clouds. Otherwise, we'll set it to the Dirt Underground. So really quick, let's give ourselves a better pickaxe. So the ID of the silver pick is 15, so let's set the held item number to 15. That way we can dig down to see if our background's working. So you can see it's a cloud right now, and if we go ahead and dig down deep enough, hopefully it should switch to the dirt layer. Yep, look at this, we have a dirt. It's dirt now. Next, let's do the stone layer. So this right here seems like a good threshold. So 6,500 pretty much. So go ahead and duplicate this like so, and check if the scroll Y is greater than 6,550. Then we'll do the Dirt Underground. Otherwise, we'll set it to the cavern background. So you can now see that once we get into the cavern background, yep, look at this, it's the stone layer. Okay, so that is looking great. Now the transition isn't great, so let's make it fade out. So go ahead and make a variable called _old background for the sprite only. Set the old background to a random number in the very beginning, and then right here we can check if not old background equals to background. Then we broadcast and wait a message called switch background. Then once we're done, we set the old background to the background. Now when I receive the switch background, clear the graphic effects, repeat 5 times, change the ghost effect by 20. Then we want to make a variable called costume. This is for the sprite only. This is so we can hide the transition. So set the costume to the background. Then we want to duplicate this right here, which is the set parallax speed. Then duplicate this, just to repeat 5 times, and then do -20 here. Then once you're done, clear the graphic effects. Now up top here, we can, instead of switching costume to the background, switch costume to costume, and in the very beginning, right underneath here, set the costume to background. Okay, so hopefully now we should see that the background will fade out and fade in to the different background. So we can go ahead and dig down, dig, and you can see, look at that, the background actually fades instead of just teleporting to the background, and it looks good and everything. Now if we go back up, there we go, it fades, cool, it's seamless no matter what we do, it just fades in and out. Okay, that looks pretty awesome. And then if we go deeper, there we go, stone layer. Okay, so now let's make it to where when we're underground, the background is dark. So inside the backdrop, go ahead and do a when I receive switch background, then add an if else, checking if the scroll Y is less than 7,000, then switch costume to underground, otherwise switch costume to skybox. So you can see now, hopefully when we're deeper, it should use the dark skybox. Right now we'll see light one, then look at that, the background's dark when it fades in, and then see now it's black fading in instead of the lighter one. Okay, this is good. And the reason we set the old background to a random number is because this is checking if they don't equal each other. So this will basically force it to update in the beginning. Okay, so now onto the more complex part of the episode, we need to add the lighting engine in. So first of all, add a list called tile light level, like so, and click OK. Now in the backdrops underneath the create tile meta, go ahead and delete all of the tile light level, then repeat the world width times the world height, which gives us the total amount of tiles in the world, add 0 to tile light level. And if we start this game, you should see that here we go, we have a big list of the light. Okay, so now we can actually use that. So in the tile manager, right in the tile VFX, in this else, set brightness effect to duplicate this and change this to the tile light level. And you can see that it looks exactly the same if we start this game. Awesome. Now we need to make a block that will calculate the lighting. Now this will only be called when the tile loops. Otherwise, if we call it every single frame, it will lag the game out quite a bit. Make a custom block called calculate lighting, like so, and click run without screen refresh, and then click OK. Now go ahead and run calculate lighting underneath all these different looping here. Make sure it's inside the loop, not outside. Now we need to add a parameter for the tiles to check if they are affected by lighting or not. So edit the create tile meta and add a label called affected by lighting with a colon, then an input affected by lighting, like so, and click OK. Now we add tile data affected by lightning, then we can fill out all the data. Air is not affected, so it's false. Bedrock is affected, so it is true. Stone is affected, so it's true. Dirt is affected. Grass is affected. Long grass is not affected by light. Flower is also not affected by lighting. Wood and leaves are not affected by lighting. Leaf logs are not as well. Clay is. Torches are not. Bedrock dirt is. Ladders are not. Tin ore, coal ore, copper ore, silver ore, and gold ore are. Okay, so if we start this game and we open up the tile meta, you can see underneath the mine time, which is a number, as you can see, 2 for the stone, it says true, which is the if it's affected by lighting, whereas flower is false. Okay, that is good. So to get the if it's affected by lighting, we need to add 4 to the grabber. So right at the top here, we can check if it's affected by lighting. So do an if item 1 of tile grid and change this to the item tile list ID of tile grid and add 4 to that because that's the amount we need to shift it by. Then do the item number in the ID grabber tile meta and put that in there, and then check if that is equal to false. So that means that the current tile is not affected by lighting. And we replace the item tile list ID of tile light level with 0, so it's unlit. Then to make sure that we don't run the lighting engine, then stop this script. And for now, let's go ahead in the else here, replace that with -50. So any tile that is affected by lighting should be really dark, otherwise it'll be normal. So you can see that all these are dark, and that's because I did this grabber thing wrong. What we need to do is take this out and then do the item number of ID, which is this. Then we need to add 4, so it shifts it to the right to get the false. Then we need to do the item of the tile meta and put that in there. Now, if we put this in here, all the blocks that are affected by lighting should be dark, and otherwise they'll be normal. So you can see that all these are normal because they're not affected by light, but these ones are dark. Awesome. And it automatically updates, and it's not too bad for the performance. Okay, now we can work on the real lighting engine down here. So go ahead and get rid of this and make a for the sprite only variable called tile light for the sprite only, and then another one called light position or light pause for short, and click OK. Now right here, set the tile light to 0 and then set the light position to 1. Then repeat 5 times. Now this is how many times it'll smooth out the lighting. The more times the better it will look, but it'll take much more resources. Now we need to check if the tile we're looping over is affected by light. So check if, duplicate all this, and then do true. And instead of just doing the plain tile list ID, we want to add to that the light position like so. So if it's true, then we change tile light by 1 so it gets a little brighter. Then underneath here, to increase the loop, we change the light position by 1. Now once we're done looping through, we set the tile light to itself times -12, so it inverts it and it takes it times 12. Then duplicate this guy right here, and instead of doing 0, we replace it with the tile light. Okay, so this is a pretty big script, but hopefully it should add shadows to where it gets darker the longer it goes without having a open block. Yes, look at this. You can see that, wow, there are shadows. So basically how this works is each time the tile gets looped, it'll run this custom block, then it'll check if it's affected by lighting, and if it's not, it'll just make it bright and skip this and stop the script so it doesn't do any of the lighting. But if it is affected by lighting, then it'll reset these variables and it'll repeat a set amount of time, in my instance 5, and it'll check if the tile above it is affected by lighting, and if it is, then it will change its tile light by 1, so that'll make it darker because we actually invert it later, and then it'll just increase the light position by 1 so it moves up a tile. Then once it's done doing that, it inverts the tile light to make it dark, and then it'll just replace its lighting in the list with the tile light. Now this is awesome and all, but if I go ahead and dig around, you can see that it doesn't actually update and it stays dark even though we're digging under here. So we need to make it to where the tiles update each time you break a block or place a block or do any interaction like that. So add a when I receive and do a new message called refresh tiles. Then we'll just run calculate lighting. Then in the selector, right underneath the break tile, broadcast refresh tiles. Now you can see that if we start this game, hopefully whenever we break a tile, it will actually update the lighting engine. So you can see boop, boop, boop. Yes, look at this. It actually updates a lighting engine and the performance is actually pretty good. Now, of course, this isn't the most realistic and best engine because you can see if I keep mining up, it just gets lighter. It only really works for 5 blocks, but like I said, you could increase the accuracy or you could make your own engine that's a lot more efficient and cooler. But for a game like this, I think it fits okay. Now we have a cool lighting system that actually looks pretty cool and it gets darker when you go underneath the ground. Awesome. Now, like I said, you could go into the tile manager and then change this 5 to like a 10, say. Now, as you can see, it actually gets darker and darker and there's more steps to it. Now, this is actually a little bit too dramatic, so instead of -12, let's do -6 because it's double the amount. So you can see that the lighting engine looks a little bit more realistic and it has more steps of light. So you can repeat more times, it's just going to have a bigger performance hit. As you can see, there's a little bit of a lag spike whenever I break blocks because of the massive amount of repeating blocks and stuff. So I'll change this back to a 5 and then a -12 here. And one last thing that I think really improves the look of this game is by darkening the player and all that stuff when we are underground. So inside of the player, scroll up and add a custom block called lighting and click OK and run lighting underneath here. Now inside the lighting, get the current tile X and Y, make a new for the sprite only variable called player light level and set that player light level to we need to find the brightness of a bunch of blocks around the player. So do the item player tile index of tile light level and add 1 to the player tile index. So that's the tile right above the player. Then add to this, duplicate that and do 2, which is the block above that. Then add to that, then duplicate the main one and add 3 to that. So to add on the brightness of the block above you, the one above that, and the one above that. And then set the player light level to all that. Then make a new variable called global brightness. Click OK. way and change it by a minus here and take the target position, which is the average of the player light level. So take the player light level divided by 3 because it has 3 different items, subtract off its current, then divide it by 10 to smooth it out a bit. Then last but not least, all we need to do is set the brightness effect to the global sprite brightness. And you can see now that hopefully it should be bright on the surface and it gets darker when we go deep. So you can see that now if we go down here, dig a little bit here, yes, look at this, the player smoothly gets darker when we go under here. Now it does look odd though because the pickaxe doesn't look dark. Pull the set brightness to global brightness in the held item and then run that right here, and you can now see that hopefully the hitting looks good as well. So you can see the pickaxe looks normal, and then if we go into a dark spot, here we go, look at that, it darkens with the player as well, and that looks really cool because it actually looks like we're underneath something. Now eventually we will actually come through here and add like a vignette around the screen that gets darker depending on the light level, but I kind of forgot to add that in the beginning, so we'll do that in a later episode. Thank you all so much for watching. I hope you enjoyed this video. Make sure you hit that like button and consider subscribing. Anyway, this has been Owen, and I am out.